Welcome to clickmyproject.com. Let's discuss on the title, Do you waste laptop battery to light the room? Laptop computer has continuously grown its influence on the computer industry, outstripping the desktop computer by 3 to 1. Among the design issues of laptop, power management that prolongs a battery life is crucial. In a typical battery powered device, the display component consumes a noticeable amount of total power consumption. Although the power consumed by the display varies across the laptop, the ratio from the total power consumption appears to be similar, around 30%. The display consumes such amount of power to provide high quality screen to the user. However, when the user is not gazing at the display, there is no reason for the display to be turned on unless it is turned on to light the room. Thus, noticeable amount of power can be saved by turning off the display when the user is not gazing at the display. So we propose a scheme that uses a webcam to capture the picture and identify the state of a user in a fine-grained attention level. The proposed scheme classifies the present state into two states and the intermediate state between the two states. The attentive state where the user is gazing at the display, the inattentive state where the user is present but not gazing at the display, and the weakly attentive state, that is an intermediate state, which is used to minimize potential direction errors. Now let's have a discussion on the data flow diagram. Regarding the data flow diagram, you have to select an input video which was captured from webcam and you have to convert that into frames. Each frame has to be subjected to face detection algorithm using hard face detector. After that, you have to provide the detected frames where the face is being clearly detected. Those frames must be given to moment invariant feature extraction algorithm, which will provide you with the feature values for each frame. So using those feature values, you have to train a Bayesian classifier by providing the labels of 4 states which have been discussed earlier. So depending upon the training, you have to test the frame one by one to know the status of the person. Then appropriately you have to display the status message as an indication either in a message box or in the command window. So depending upon the test frame input what the classifier receives, it will provide you with the result either to be interactive, attentive, inattentive or away. Now let's see the execution of the program. Regarding the execution of the program, you have to select this main program.m and press run file. A video will be displayed which was captured using webcam. Those video will be having all the 4 states that has to be figured out in the program. So this is the input video. It will take some time to load. This particular video says the attentive or interactive state. And this particular frame's positions will represent the attentive state. The user is gazing at the process taking place in the laptop. Now the user is been gazing somewhere else, not concentrating on the laptop screen. And now the user is not available in front of the screen. At this time, a message box indicating away should be displayed. So this is the input video and frame conversion has to be done. Next, you have to implement hard face detector algorithm. It was implemented based upon Viola-Jones algorithm to detect the face region of a person alone. So the command window, what you see is the face detection algorithm execution, displaying the frame. So wherever the person is not available, the status will be displayed as away. The execution is done for the last 5 frames to display the away state. When it is executed for a whole program, that is for a whole video sequence, it may take some time. And this is a graph depicting the status of each frames. How many frames are being thrown as interactive state, how many has been thrown as attentive, inattentive and in away. This is the accuracy percentage. This is the confusion matrix. This is status indication, which indicate to switch off the system as the user is not gazing or user is not available in front of the window. By this way, you can minimize the laptop power consumption. So in this paper, we propose a user-aware power management scheme to save power by examining whether the user is looking at the laptop display. Since most laptops being sold these days are equipped with webcam, the proposed scheme can be applied without any additional hardware. Thank you.